I've been in the data collection business from the shop floor since probably, probably since the mid-80s, and there's a picture of a nubile me in the Central America. Now I'll put that slide up more for my colleagues really, who just to show that I wasn't always bald and fat, but things have moved on, and that was in the analog days as well. That's well before. I think pocket calculators were actually all the rage at the time. So there you go. So I've been around a little while, as you can probably tell by looking at me. So, and so have the roads. I don't know if anybody recognises that network there. It's actually the road network circa 43 AD. So we've had a road network for quite some time now. And I'm actually quite impressed with how much we had back then, really. But I suppose, things have changed, we've moved on, and we move around that network much more freely and much more safely than we did before. Or maybe not. Things do go wrong. We've been at it for a long time. As engineers, I've been at it, as I've just pointed out, for a long time, but, things do go wrong. And that's the thin end of the wedge when it does go wrong, of course. And, and it gets to the point where we could lose lives, and that's the worst case scenario. And sadly, in my time, I was involved in the Potters Bar rail inquiry as an expert witness. Again, at the real thin end of the wedge when things go wrong. That represents the net result of a whole lot of systematic failure, where a whole sequence of things broke down, particularly around the maintenance side of things. And I guess it's worth just looking at what's meant by systematic failure. I mean, there's a bit of text there to read. I'll help you out. Okay, it's failure related to a deterministic way to a certain cause, which can only be eliminated by the modification or design of a manufacturing process, operational procedure, documentation, or relevant factors. All throughout today, we've been mentioning certain elements of that. Okay, so, we've been talking about trips and slips and one thing and another, but when all of this really mounts up and goes wrong, the implications can be catastrophic. And I sadly had to sit through all sorts of accounts of the Potters Bar rail inquiry. So that's not ever been lost on me, really. But we do have an army of people that are out there dedicated to keeping our roads safe. And they do that in a systematic way. They don't just get up in the morning and decide what they're going to do. We have systems in place to do that. And that system should always be changing. It should never be static, because the way we use roads is always changing. The types of road users we have change all the time as well. So it should always be adapting and improving. And I guess the key word is improving. We should always be improving the way that we manage things for safety, and thereby reducing risk, of course. And the road network. Let's talk about this. Much maligned, I guess. 250,000 miles of the road in the UK, and it's the oldest, it's probably the most valuable and probably least appreciated asset that we actually have. And like I said, it's been around, well, in the early stages from the Roman times, so from the birth of Christ. But we still don't know enough about the roads. We make a business out of collecting data. I can tell you for a fact we don't know enough about the roads. There's a lot more we can find out as well, a lot more we can do. And I suppose data and collection of data has been around for quite a while as well, and I'll come on to that. But let's just talk about why we need data. I mean, look, we've just had a big session about data, and we've been talking about data all day. And the very obvious thing is that our money comes from that, really. Valuations, capital funding, challenge fund bids, etc. Maintenance planning. None of this is guesswork. It's all based on some kind of data. And Steve sat here on the front. I mean, he's got to make a case to Treasury, of course, and his colleagues. And they don't just do that on the back of a fag packet, of course. It relies on data, and that data comes from somewhere. And it's what's been collated from, you guys, essentially. And obviously, we help in that process. And it has to be good data as well. I had a bit of a chat earlier with Eddie on the table there. There's data and there's good data. You can get lots of data and you can do all sorts with it, but if it's not good data, you're not going to get the right answers. And there are cases where having too much data, as we talked about earlier, can cause us problems as well. So really, the kind of data we've got, the way that we present that data, the kind of business plans that we put together, it really relies on good empirical evidence, and that probably goes back as far as the Romans as well. You know, I bet you they didn't just put a network together based on, you know, where should we go this morning. You know, there would have been some kind of planning involved and some kind of data that they would have used. And that's just good asset management. You know, the asset management is by definition financial management, because you can't manage an asset without money. And you know, you go to any financial manager and you know, again, it's going to be all related to data. And Christina pointed out what happened in the financial sector when they decided that risk was something they could worry about another day. You know, it went catastrophically wrong for everybody. So we've been collecting data for a while, and of various sort of techniques that are out there. Some of them probably date back to Roman times as well, but still, we've been using deflectograph, we've been using scrim and scanner and CVI and DVI, and it's worked well over the years. It's done its job. But you know, engineers have been the people who have been driving that. But that's not going to be the case forever, and in fact, it's not the case now. That's a bit, we've all seen cyclists with helmet cams, not probably quite as many as them, but there's people out there collecting data right now, and not just a few people. There is literally millions of people out there collecting data right now. Now, there are systems like this. This is C-Sense. I know the CEO of this company very well. I was actually out in the Southeast Asia with this guy a little while ago. That's a very clever piece of gear. It's monitoring air quality. It's got accelerometers on there. It's connected to the internet. It's now got cameras. That's just on a bike, and it's probably less than 50 quid. You know, and these are selling like hotcakes, and certainly abroad there, certainly in other parts of the world. I don't know for a fact because I've been there. These are, so there's an army of centres, well not army, there's thousands of these centres out on the street now, collecting data. If you go and fill up at a filling station, you can go in there and go and buy a dash cam for about 15 quid. So, you know, you probably looked at our videos, you see that we've got cameras on vehicles that cost us thousands of pounds. You can get that for tens of pounds. So there's people out there collecting data. Again, there's certainly that's going to be lost in the insurance industry, and I think there are some countries where chances are you won't even get insurance unless you've got some kind of camera. And it also makes for good YouTube if you watch what happens in Russia on the roads as well. Right? So, you know, again, more data coming in, and even more data coming in. We've got sensors on vehicles. I think the standard car now, I think it's quoted as having about 200 sensors on board. 200 sensors in a car. Times by how many cars? I don't know how many cars we've got, maybe 100 million or something. So you want, so 200, I don't know. Millions and millions of sensors out there. Just ask yourself how many sensors you drove over in the road and on the bridges that you passed over to get here. Despite the fact there's all these millions of sensors on top of the roads, there are literally none in the road. So we're in a strange place with that, really, I guess. I just made that point for what it is. But that data is being collected. But there's also another source of data as well, and that's us. Social networking. I don't know anybody who's not on social networking. I mean, my kids were on social networking a few years ago. They're not very old. It's everywhere, obviously, and we can see what happens if we have a disaster, a riot, etc. Riots are organised by Twitter, etc. So it can be a force for good. It can be a force for evil. You know, it can be used against us. But largely, it's all about people feeding information into the internet, and it's all recorded, and you can access it, you can georeference it, you can do things with it. So it's a resource, really. Now, if we don't, it's a resource for good, as I said. It can also be a resource for bad. Now, this is the kind. I mean, there's lots of examples like this on the internet. Some far too obscene to put up here this afternoon, although I was tempted. You know, that kind of thing goes viral very quickly. Perhaps not that, but some of the stuff I've seen has. And, you know, who's driving the agenda then? So this data is there. This information is coming back, and it is creating influence out there as well. Now, that was unorganised data, and it's not much of a threat when it's like that. But let's have a look at organised data. This is OpenStreetMap. For everybody who knows what OpenStreetMap is, it's a crowdsourced map, which is as good, well, it's probably rivaling Ordnance Survey's network and etc. now. People have been building networks or mapping for hundreds of years. This is what people can do, and they're not getting paid for this, they're just doing it off their own back. So the power of getting little bits of information from lots and lots of people and putting it together in an organised way is absolutely immense. And that's a force for good. We can now get maps, and we use it in our business. We use OpenStreetMaps and all because it reduces costs, and we don't have to pass that on to the customer. So good. So that's a good use of it, of course. But it's getting even more organised as well now. At a local level, that was a national level, so that's a national map. But this is just an example I found on the internet. Canada, mapping their community, people mapping things at a local level, which is great. You know, and let's celebrate that, because we can do lots with that. It can tell us a lot about the place where we live. Now, I come across this system as well. So this is just one I browsed upon. It's not that I've spent any time studying this. WalkScope. It's really pertinent to what we're talking about today. It's again, I'll read it for you, but it's a mobile tool developed by Walk Denver and Place Matters for collecting data related to sidewalks, intersections and pedestrian counts in the Denver metro area. This information will help create an inventory of pedestrian infrastructure, identify gaps and build a case for improvements, and use the map to explore the data collected to date. Let's just concentrate on the case for improvements. Who are they making a case for improvement to? And my guess is it's your counterparts in America. The people who manage that footwear network are now going to have people come to them with all sorts of data. Now that data isn't very, ad hoc bits of Twitter feed. That's the kind of data that they're presenting, and it gets better. So that's at a network level. Now look at that. You probably can't read it from here, it will be on the slides. But there's all sorts of information there about what people think about their sidewalks, or footways, I guess we'd call them. Visibility, lighting issues, what's that? Traffic speed, volume, other safety concerns, etc., etc., etc. That's an incredibly well ordered and well presented set of data. In fact, I'd be proud of that if we were delivering that to our customers, if I'm honest with you. And that's just a group of people, just a group of volunteers in one small town. Now, what happens in America, sadly, comes here eventually. So it won't be long before we see these kind of community projects with data. People understand data. My kids understand data better than I do. They're used to this. That's what they want to do. It's I hope they don't do it too much, because we've got a business that invents data as well, so we don't want them to compete too much. But still, this is really, really interesting. It's an interesting view on what can happen and what could be happening very soon. Let's not underestimate how these trends actually change. So, whether we like it or not, we have to live in a world with data. It just will not go away, and we can all sit like King Canute and hope the tide goes back out, but it won't. And I guess none of us have missed the term big data. It's a euphemism, I guess, for some kind of natural resource that's been sent to save us from ourselves. Is that just an overused buzzword? We already have lots of data, obviously. So is it big? At what point does it become big? Have we got big data now already? Well, if you think you've seen big data now, wait for this one. More data will be created in so this is a bit old already, but more data will be created in 2017 than the previous 5,000 years of humanity. That was in 1 year. What's going to happen this year? What's going to happen 5 years from now or 10 years from now? How much data will we really have? And we had a big, as I say, we had a debate about quality data. So we're going to have to really deal with this information world. It's coming at us. We can't avoid it. And there are certain catalysts to that as well that are going to cause it to happen quicker than we might think. Now, the sort of next big revolution, of course, is in connected and autonomous vehicles, which will be slightly more advanced than that, I hope. The relationship that we have with cars will change. You know that. I mean, everybody knows what's going to happen, I guess. Or at least, well, nobody knows what's going to happen, but we've got a good idea of what's coming down the road. The way we operate cars, the way that we fund cars, the way that we fund roads is all going to change. This will be the biggest revolution in transport since the invention of the car. In fact, probably since we found we could sit on top of horses. Transport will change massively. And there's not a small amount of money going into the investment in that. there are organisations around the world investing billions. And that kind of investment creates change. Like we just talked about, there's change happening already. But when you sort of supercharge that with billions and billions of pounds worth of investment, there's going to be a lot of data. Now, driverless cars, as you imagine, are packed with sensors. We just talked about sensors on the a second ago. Excuse me. But if you thought we had a lot with 200 sensors, wait till those things hit the street. So we're going to be thousands and thousands of sensors in there, and very sophisticated sensors at that. The kind of lasers that they use now, not so long ago, we'd be paying at least £250,000 to have something that would rival the accuracy, and there would be about 5, 6, well, maybe 10 times as big, probably even more. And they need to be, because those cars, they need to know everything about that environment. They need to know everything about that infrastructure. So if they think we need data, you imagine being a driverless car and navigating yourself through that little lot. You know, they'll need to know just about anything they can. So those cars are going to collect a phenomenal amount of data. But it's the relationship that they have with the infrastructure that is going to change. The way we drive and the way a car drives and the kind of decision making that we make and the kind of decision making that a car makes are two totally different things. Just take a lit street. You might, well, what's going to change there? But do you think about it? We're lighting streets for pedestrian and car drivers right now, but soon we'll be lighting streets for cars. What are they called? Tesla. Tesla are trying to move away from lasers and use cameras, because cameras give them a whole lot of additional data that lasers don't give. Cameras need light. By definition, a camera is a light box. So it needs light. So the way that we light streets would potentially change. And how are we going to do that? The next one, which is a bit more obvious really, road markings. We can make sense of those. Just look at that little wiggly man down there in the corner. How would a driverless car make any sense of that? So the kind of road markings that we've got now, we're going to alter as well, without a doubt. And we'll be putting sensors in there and all sorts of stuff that we can't even think of will be thought of and will be in there. So that we'll be reordering the network, which is not a small job. We're just trying to talk about keeping it safe, let alone redesign the whole thing and lay a whole new kind of infrastructure for the future. You know, that's going to be a challenge. And why? Because how is a driverless car going to make sense of that? It'll just go screaming across that. So we've really got to think, well, you know, it's not here tomorrow, but we've got to think about the future a little bit. The way that networks are going to alter, and certainly some of the funded streams that are coming out from the DFT right now around connected vehicles, autonomous vehicles, there's a reason for that, because these guys realise what's going to happen. There's a transport revolution. And if we as a country want to lead on that, we've got to have places that these cars can drive, we've got to have places that these cars can be tested. So the infrastructure needs to catch up to where it's going. And technology is moving at a massive rate of knots. So, you know, there will be a gap soon between what the demand and what we can actually supply. And this is just, you probably can't see it too well, but we as a business are doing the same thing. We're taking the kind of lasers that are used on cars, and we're testing that now to see what can we do with that. What will cars be able to detect? What can we detect? And we're finding early correlations now between being able to identify defects. Just early work, but we've got to get a grip of this, because it's going to come, whether we like it or not. So we're going to end up there, this nirvana of transport. So we're going to live in these clean, bright, well-swept cities where cars are driving around in total harmony with the people who live there. And nobody will get knocked down anymore, and we'll never be late for work, and it'll be fantastic and brilliant. And let's hope that's true, eh? But, you know, we've a long way to go, because the reality is quite different. You know, we're not there yet. And doesn't mean to say we can't get there. You know, let's be a little bit optimistic. Greg's, follows me on that one. But, you know, we can. But there's a lot of legwork to go through. And there's a long way to get to the point where we've got the network to a point where these cars or whatever, in fact, never mind these cars, where people want to live. You know, you don't want to live on that street, do you? Let's face it. I mean, there's nothing wrong with the houses, but it certainly lets it down. But it's a big job, you know, and we've talked about data and you know, we collect it all the time for people, and the stats are ridiculous. And I'll just give you an example. So Lancashire County Council is one of our customers. I picked them because they're reasonably big. Not the biggest. But if we took their roads and laid them end to end, I don't know if anybody's got any guess, or what, ask, because you might know, but there's the distance that you would travel would be equal to London to Tibet. That's Lancashire County Council alone. How on earth does a network manager or anything carry that kind of volume of information in their head and be able to make snap decisions about where we're going to put maintenance or whatever? No wonder it's a big job. No wonder it's difficult seeing our way through all that data, because there is so much of it. Absolutely masses. But being able to understand your network at that sort of level, or a very sort of granular level, is important. And Tony King's going to like this, because this is a picture that Tony took for us. We were having a meeting with Manchester just last week, and that's right opposite the meeting room. It's out the window, I guess, Tony, is it, from where we had the meeting? And this is a classic example of why knowing your network, particularly in regards to sort of risk, is important. That bit of footway there is inspected as a fairly high priority, isn't it, I think? Yeah. This is the middle of Manchester, just around the back. There's hardly any traffic down that footway, as you can imagine. Didn't go anywhere much, off to a bit of a private car park, is gated off. Not a great deal of traffic. So does that really need the same inspection regime as that? That's a different kettle of fish completely. And there's probably literally hundreds, if not thousands, of those bits of network that we could, if you like, put into a different regime if we only knew the network better. But knowing the network, as we can see, is massive. Manchester, what will that be? 800 kilometres, Tony? So it'll get you part way to the south of France. So, it's a lot of network to understand. So getting that information in and being able to assess it that way from a desktop, because sending out fleets of people from here to Tibet is not a really good idea. It's not a very cheap idea anyway. So being able to bring that information in and make sense of it is key. And of course, that's where people like ourselves come in. We have that kind of technology. I'll mention that in a minute too. We go around and we use video. And we use video for good reason. Same reason as Tesla uses video. And if it's good enough for them, it's good enough for me. Because there's lots of information in video that you don't get from other sensors. The same way as the video is no different to your eye in many ways. So there's lots of information in there that we got. And there are lots of video or imagery out there. And Google's no stranger to putting out vast amount of imagery out there. But is that any good for us to make a highway assessment, some kind of assessment of safety, etc.? Certainly not. That's the village that we live in. That was taken in 2009, so it's not exactly the most up-to-date data. And if you look down onto the carriageway, it's all pixelated and a bit sort of useless, really. Having said that, in the middle of Manchester, which I've just mentioned, the data is more up-to-date and is more relevant, and you can get more from it. But as a consistent source of data, notwithstanding the licensing implications, it's not really the most reliable. Excuse me. So that's what we do. We take a higher resolution look. So I'm talking about technology, so that's what I'm here to do. We're using video to identify the network and all of the, fence-to-fence, footways, textured surfacing, cycleways, parking issues, you name it. If you get that right, you can pick up a lot of extra stuff. And again, it's a very quick way. If we've got a network that extends to Tibet, chances are you want a fast way of doing it, or a very, cost-effective way at the very least. And being able to use this kind of survey technology means that we can pick up what would be a number of different surveys in one. So footways and cycleways and signs and trees and parking and TRO signs and signage that's obscured by vegetation, which I was talking about at lunchtime. They can all be picked up from one pass. So that makes it much, much cheaper. So here's an example. It's our example. There are other companies that do similar things. An example of using technology to drive the cost down and to bring that data back in. I'm just going to delight you with a bit of a video now. All going well. See if it works. If it doesn't, I'll have to think of something really quick. So this is what we've done with video, taking it to the next level actually. So what you're looking at there is Google Earth. We don't have any responsibility for that imagery. As you come in, it's pixelated, and this is the whole of York, their network. Inside of that green banded area is the imagery that I've just shown you taken from a vehicle. Now what's taken driving down the street, so it's taken from a driver's eye level. And what we've done is we've deconstructed that imagery and reconstructed it as like a bird's eye view, an aerial view, almost as if you had a drone. So we're now zooming in, zooming in, zooming in, zooming in, zooming in, to a point that gets us to what is 900 times the resolution of Google imagery, which is what I showed you earlier. And this outfit here doesn't really show it the right resolution. We can see that ironwork there belongs to Yorkshire Water, and it's a fair assumption to make that that dodgy reinstatement also belongs to Yorkshire Water. And we can see the quality of the road markings, etc., just from that image. As we zoom out, we can start to see the state of the road. Also, this imagery removes all the cars as well, just in case everybody's thinking there's no traffic in York. I can assure you that's not the case. We can start to see cracks, we can see hubcaps, and Lord knows what else. So again, what that's done is it's brought all of that network that exists from here to Tibet and brought it into your desktop. So you don't have to go out, you don't have to send people out in vans. Lancashire, it would take you about 2 hours to get from one end to the other, at least. So again, leveraging technology to sort of bring data back in, that's fine, but you know, we then got to do analysis on that. Here's another view of the same thing, just in case that video didn't work. And you can see we've got the footway. That's just from one of the 5 views that we've taken. Now that's taken us 4 years of research and development with the University of York to get to that, so it's not an easy feat. And in that there, I can assure you there are several hundred images all stitched together. Now, the important thing about that imagery is that's, if you like, the base data for where we can go next with this. We can start to use deep learning technologies, Steve mentioned earlier, artificial intelligence to start doing the job of an inspector. However, big caveat, it is going to be a long time before we can replace automatically the role of a human, particularly when we're looking at something as nuanced as a highway. So it's going to be years before we get to the point where we can just, yeah, whatever, hit a button and that's it, sends a report off to Steve Berry at the DFT and it's all job done. It won't be like that. But it won't be like that for a long time, let's put it that way. But we're working down that route, if nothing else, is to shave off cost, pump up productivity, and just really make the whole thing a bit cleverer than it is right now. And also provide empirical evidence, because we talk about being up in front of a brief somewhere. You know, we've got it there. We can take that, we can present it in court. I presented video in court at the Potters Bar Rail Inquiry, which was 10 years ago or more. So video evidence or imagery like that is evidential, as I'm sure you would agree, Greg. So it gives us a bit more of a tool in our armoury, and again, just some more images there. Now, that's at a very granular level, of course, as well. There's a network level, a strategic level, which we've talked about before as well, making the strategic case. Now, we've you may or may not know, just thought I'd broadcast this while I'm here, that we've gone out and we've surveyed every single A, B and C road in England. That's mapped slightly inaccurate. We didn't do the Isle of Wight, largely because we think it's nearer France and more French than it is English. But we've done England, let's put it that way. And we are just about to move into Wales, hopefully this year. All of the defects, all of the volumes of material, etc., is there, so that we can start to get that big data that we talked about. Because this literally is big data. That's like the big bang of data for the highway sector. 150 kilometres, if you want to test it, would drive you around the Earth 5 times. 150,000 kilometres, should I say. At 900 times the resolution of Google Earth. It took us 5 or 6 years to get to the point where we even had the infrastructure to be able to do that. As you imagine, for those who can work it out, we've got to be careful because I know there's some people from the software house here, but I think we're looking at 1.5 petabytes, which is, I believe, 1.5 billion megabytes of imagery. So that's a lot of data. But it's base data for us to do a lot of analytics on, to really give us the information that we need to impart onto our customers, like deterioration curves. How do these roads behave, and under what circumstances? Now we've got the whole of England. We can really start to look at how different roads behave in different places, and that gives us the statistics we need to start driving into the models we mentioned a little bit earlier. You know, what happens if we spend this amount of money? What happens if we spend that? What happens if the DFT give it all to Carillion or somebody like that, and we can't spend it on our roads. You know, what'll happen? And we can look at that. We can risk assess that now. We can spread that risk. We could look at what would happen if we start to see through some, you know, climate change, harder winters. Does that really drive down? Well, if it drove down the condition more rapidly, what does that mean in terms of funding? And this, of course, as Steve was saying before, the DFT need to make a case to Treasury. Feeding that back into the DFT is important, because then they can go cap in hand to Treasury and say, look, you know, this is what's going to happen. You know, we need infrastructure to deliver all of this industry, all of this commerce needs a thriving infrastructure. If we want to be ahead of the curve with driverless cars, we need to have a good infrastructure. So we need, when this is the amount of money we need, but this gives us evidence now, because we've got that level of data, that level of detail, we've got evidence to make a business case, which is what Steve was saying earlier. That if we've got data and we've got a case, well, then we can be using that case to leverage more funding, which after all is what this is actually all about. Asset management is financial management. You need money. If you don't have money, you don't have an asset management plan, that's for sure. And I'm sorry if I sound like I'm teaching it, it's okay, because of course you know that. I'm just obviously labouring the point. Steve mentioned it earlier, we're involved as a technology partner in the Pothole Spotter project. Great name for getting on TV, but not a really good name at describing what it does, if I'm honest. This is a similar kind of exercise, but at another level. So we've looked at masses of data across the whole of the country every year, but what we wanted to do as well is have a look at lots of data of the same place every day. What's happening to these defects? How are they, you know, how well are reinstatements like that holding up? What happens when we start to get a small defect? How long till it gets to be a big defect, but and on what kind of roads, etc., etc. It's all about material behaviour. It's all part of that understanding how things behave, the analytics that we can start to bring to bear on these problems of prediction, of deterioration modelling, which is key. If we're going to make a case, you know, funding, asset management plans don't want to last a year. They want to be lasting 10 years, 15 years. So we've got to articulate very carefully, or very clearly, what 15 years of asset management look like, the funding levels that we're at, or whatever. It's intrinsic. We believe we're in talking about risk, highways inspections, etc. We believe that's the next area for us to innovate in there. I don't know if it's like a £20 note. We need to get the location of that, somebody. We need to understand, we need to innovate that. There's a lot of, it's not the most productive job in the world, shall we say. There's ways that we can innovate that. But again, with the caveat, we can't take away the human decision making in that. We would proper lose some some cases if we stood up there and said, well, the computer said. We need to have people make a decision. But how we collect that data and what kind of data we give them to work with can be innovated. I'm certain of that. And we're working on another, what we're looking at doing is putting same kind of video systems, but actually now nearer the ground, looking at more agile systems. That's an e-bike, an electric bike. Because with the best will in the world, highways inspectors don't want to pedal all the way to Tibet and back for a job, but although there would be the benefit probably physically from doing that. So we're looking at how we can bring technology in and devise robust business flows, if you like, around that data, so that we can at any point speed the whole process up. But taking the point that, you know, if you're not careful, you bring in far too much data to be able to deal with. And again, that risk-based approach will have to be brought to bear to sort of deal with the problem that you brought up there about, if I know all this, I've got to deal with it like here and now. But just demonstrate really that there are these technologies coming through now, primarily aimed at bringing more information in and identifying safety. Because at the end of the day, you know, really, it's about road safety. Even, you know, normal preventative maintenance, if you take it to its nth degree, is about road safety. So there are this technology, and we've taught there's pothole spotters and there's other trials, and that's just our company, and there are other companies. So there's other countries that are trialing different technologies. So technology is heating up. Anybody who's watched the news lately can't have missed the phrase artificial intelligence, of course. And it's being driven into everything. I was looking at some on the news this morning. and there was some AI solution for telling you when your dog needs to go to the toilet, for example. So if it gets to that level, you know, you can bet your bottom dollar we're going to be using it in these kind of industrial applications like that. And we as a company are doing that research now. So, but the network doesn't just consist of roads, of course, and if you didn't have a bridge, you wouldn't have a network, you'd just have lots of very long cul-de-sacs. And bridges are a pinch point in the network. And unlike the road surface, they are, where they're sat in a river at least, they're going to be affected by other environmental factors such as rain and flooding. And again, anybody who lives in the northwest of England, where we live, are going to be no stranger to that. There's a lot of it. And of course, you know, all joking aside, it wasn't very funny in Cumbria during Storm Desmond, and there was a massive amount of damage done to the network, and there was a huge amount of damage done to bridges, and a lot of bridges in Cumbria are still on watch because they suffer from they need to be inspected. And inspecting bridges has never been an easy thing, as you're probably aware for those who have them on your network. And I guess most do in this country. So all going well, we'll get this little thing to run. I'll just, 2 minutes, can have a watch. This was an idea we had a year ago. Oh, that's not working, sorry about that. So there we are. At this point, I'd just like to thank the DFT for letting me use their theme music for that clip of video there. I think it was the 80s. That's what I was expecting. That video was actually put together. That CGI was put together as a bit of a proof of concept. Well, not proof of concept, but a concept from. We were asked if we could bring a solution to bear on this whole issue of bridge. So there is a serious point to that. That we need to find ways of very quickly inspecting bridges and bringing back that empirical evidence to the state of a bridge. And through a collaboration with the Department for Transport, who had the vision and foresight to put the funding in behind that and work with Cumbria, we now have that system actually in the field. So it just begun work a few weeks ago. In fact, the testing begins this week in earnest. So that's one of the first shots of it. And you can see the technology there, the sensor pod that was on the video. We've got side scan, sonar, and bits and pieces. But the whole idea really is that, again, leveraging technology to give us much more evidence. That's bridge scour for those, I'm sure everybody's familiar with it, but that's what it looks like. It's extreme. You know, basically the foundations of bridges are taken away from under them, which is not a very pleasant situation to be in if you're a road user on that bridge, obviously. And it's not easy to detect. And for anybody who has to monitor bridge scour, etc., there are a number of methods, but certainly in Cumbria, the only method they had available were divers. Now, putting divers in a fast-flowing river in Cumbria is not necessarily the safest thing you could be doing with people. I personally have lost several of my friends to accidents with underwater surveys, and it's devastating, of course. And to be able to find a solution that takes people out of the rivers and puts them in front of an information display like that is something that we really want to achieve. Because that not only does it make it incredibly much safer from the inspection perspective, but that's excellent empirical evidence as to what the state of that bridge is like. That's actually the side of a pier during some testing. But you can see where it's heading. It's all about data. It's all about access to data. And if anything goes wrong, that bridge engineer can say, well, look, there you go. Or if he wants funding to put that bridge right, he can say, well, look what's happening. There's a case to be made, and you can't walk away from that. If you give that to somebody, and somebody's got to sign off, they're going to sign off on the failure of a bridge. I don't know. But it's evidence, again. It's all about evidence. So, you know, I'm getting to summing up now, really, I suppose. But, you know, we are, whether we like it or not, and it shouldn't be a bad thing, but we are at the beginning of a data revolution. You know, we see it everywhere. It's in your pocket, in your phone. Data revolution is here, and it's for us to use it, really. And this data has been democratised. I've shown a couple of examples there where citizens are using data to do safety inspections of footway. How long is it before we're faced with that in this country? And I don't think it will be long, to be honest. There is new types of technology. We stand up here as a technology provider, and we've been doing it for ages, and you know, and we take checks and credit cards for anybody who wants it. But you know, there are other technologies out there to be used right now, and you can tell from what the DFT is putting out in terms of funding, they want to encourage that as well, because it's good for everybody. It's good for them. Because technology and data used properly can drive the cost down, bring productivity up, can give us evidence, can help support business cases that have hitherto been very difficult to support. I'm not saying that children's services and adult services aren't worthy causes, and they're very easy to articulate from a human perspective. But once you start to look at what's happening to a road network, what the backlog is going to be in 15 years' time if you don't invest, it doesn't take a lot of working out that the people paying for that will be the children that are in the playground. So you can make a human case off the back of that data if the data is robust enough and it's vivid enough. And I guess investment into data really is the single most effective thing you can do, because again, you know, it's not necessarily a case of the computer says you do this, the computer says you do that, but it gives you data for you to decide what to do, and for you to be able to justify what you're doing. Then it's done its job. In a 10, 20, 30 years time, maybe we'll have a point where computers will say, computer says do this, computer says do that, and everybody go, yeah, well that must be right then. If anybody does that now, we had that debate, didn't we? Anybody tries to make that assumption now, because it comes out of a computer, it's right, has made a very flawed decision. Now, I didn't know that this was going to be your slide. I didn't know it was going to be anybody else's either. But this is a fairly well prescribed bit of an infographic there. Data, yeah, it's the information bit that really matters. That's what you need. Knowledge comes from that, obviously, but information, it's taking data and turning it into something that people understand. That's what information is, obviously. I don't want to teach it, it's okay. Data is just ones and zeros and bits of pictures and stuff. It's how we use it, how we frame it, how we present it, that becomes information. It's not, and how the context we put it in, the story we put around it, the narrative that data is supporting, that's information. And information obviously percolates up to create knowledge. But really, it's how we take that bottom line and create that second line that really matters. So it won't be long, and we will be driving around in that'll be Birmingham in a few years. We'll all be there driving these fantastic cars and watching TV while we go to meetings and stuff. In fact, we won't need meetings because we better do it in our cars and stuff. So, you know, we are heading that way, but we've got a long way to go yet. And really, I guess, let's leave this on an optimistic note. You know, the kind of technology, the kind of information that is now becoming available is what's going to get us there. That's the only thing that's going to get that. Plus, you know, technology has always really overcome lots of problems. But all going well, if we, you know, I don't know how many years it'll be. If I did, I wouldn't probably stood here. But, you know, we will get to that, but there's a long way to go. And if we harness data, we harness technology, and we can make the case for funding, and sadly none of us here but Steve can go to the Treasury and ask for it. You know, we've got to help people like the DFT with statistics and business cases and everything else. I'm sure, you know, that can be turned into funding. But, you know, that hopefully will be the scene that we all look out on. So, I think that's it. So thank you very much indeed. Obviously I'll take questions next, but before I do, I would just like to thank everybody for coming, because I do know how busy everybody is. I know how busy I am. So, you know, let alone how busy you guys are. So thank you so much for coming here today and listening to what we've had to say and what the speakers have had to say. And I would like to thank Greg and Steve and Christina and the others for really pitching in and doing that, because I found, certainly, I've got a lot of work from today. So thank you very much, and when we finish, I hope you have a safe journey home. Thank you. Thanks a lot.